Hello everyone. We're going to continue our discussion on electrical concepts here in physics class. Today we're going to be digging into series and parallel circuits. And what does it mean to be one? What does it mean to be the other? And there's some different mathematical ways that we can analyze them, so we're going to dig into that today. Two video lessons ago, we looked at this really simple sort of picture or schematic, whatever you want to call it, right? We're hooking up a light bulb to a battery with two wires. Okay, so we took it a step further and we said, okay, we can actually represent what's happening here in this technical diagram. You can see we have a battery here, a light bulb, and we throw in a switch for some ease of use. This is actually known as a series circuit. Now, what is a series circuit? I think it's a little easier to visualize with two light bulbs because this is sort of a very simple circuit. A series circuit occurs when generally two or more electrical components come one after the other. But see, they still, we can see our wiring here, the electricity flows from one into the other, right, and goes back to the battery. So think about a series, right, one comes after the other, but they're still a part of this same loop. Okay, so they're in line with each other in this circuit. Now this is a little bit different from another type of circuit that we can look at. This is known as a parallel circuit. Okay, and so here we take these devices. These are light bulbs. I know this diagram might be a little hard to see. We have two light bulbs. But see, this isn't series. They're not coming one after the other. Instead, if we follow our wire here, our electrons have a choice in where they can move. The electrons can either come through here and flow through that light bulb, or they can come over here and flow through that light bulb. We can see that in the end, they go back to the battery and they start their journey again, right? But in this case, the electrons sort of have a choice, okay? Comparing them side by side, we can see in our series circuit, they have to flow through this light bulb. They have to flow through this light bulb. Over here, I'm going to either flow through that light bulb or I'm going to flow through that light bulb. Okay, so series, parallel. Why is it important to understand these two circuits? Well, we're not always working with light bulbs. We might be working with, remember the components we talked about before, resistors, okay? And so understanding how much resistance is in a circuit is very important to calculate, say, the total current or the voltage of a battery. So we need to understand how we can add resistors in a circuit, okay? The image that I'm showing up here, okay, is a technical schematic here of a circuit diagram. And so we've taken away the light bulbs. We're now going to plug in resistors. And so we can, if we follow the wire here from the battery, we can see that there's only one path for those electrons to flow, only one path for the electricity, okay? And it's going to pass through both electrical devices, okay? So knowing that it only has one path, one option, we can surmise that this is indeed a series circuit. Now, when we add up the resistors, right, we want to add up both of these resistors to find, hey, what's the total resistance in this circuit? It's really simple. Our RT, our total, the total resistance in this circuit is equal to the value of R1 and the value of R2. Okay, so we're just adding them up. That's simple. So we can go through this example here and how we would solve this. If I'm looking for RT, my total resistance, right? It's equal to R1 plus R2. Oops. And ohms, remember our units are going to be ohms because this is resistance. Okay, and so simple enough, we don't even need our calculator. We're going to get 25 ohms. Try your best on the symbol for ohms, and we circle our answer. Okay? Simple enough. You know, mastering, adding up series circuit resistors, nice and simple. We need to understand, though, how to add up parallel resistors. Okay, here I've taken, I've taken that other circuit with light bulbs in it, and now I've put resistors in it. We can see that, you know, it looks very different. At this point here, either we're going to travel through here and then back to the battery, or we're going to travel to this resistor, through that resistor, and then back to the battery. Okay, one thing I do want to note, let's say our electron, we start up here, we come over here. Because of the electric potential difference, I'm not going to fly through this resistor, okay? All my electron really wants to do, it wants to start over here, it wants to end here, okay? So whether it goes down here or over here, once I get to this side, I just want to go back to the battery, okay? Just a little side note for you. But let's actually dig into how we really are going to add these resistances in a parallel circuit. And the equation is a little bit more complex. We can see this is a parallel circuit. Our R total is equal to 1 over R1 plus 1 over R2. I know that's kind of a confusing way to view the formula, so I'm just going to draw it out for you. Okay, RT is equal to 1 over R1 plus 1 over R2. Okay. The formula is simple enough to sort of plug those numbers in once you receive the problem. I think where this is going to be the trickiest part is really plugging it into your calculator and making sure that your work is kind of double checked. So no worries, we are going to have a good bit of practice. But I'd recommend taking down this equation for calculating the total parallel resistance in a parallel circuit. Okay, so take your time and write this equation down. And let's move on to an example problem. All right, so we need to find the total resistance in this circuit, right? We have R1 and R2 here. All right, and what I really should do, I know it is labeled, but what I really should do is I should come over here, say that R1 is equal to 20 ohms, R2 is equal to 30 ohms. Okay, we're looking for, I know it's not written down, we're looking for RT. What is the total resistance in this circuit? Okay. And I know my equation is 1 over R1 plus 1 over R2. Okay? And we go ahead and we can substitute our values. Still good to put some units when you're substituting into the equation. Okay? We carefully put this into our calculator, and we'll get some more practice through some example problems with that. But if we put it into our calculator correctly, we should get that the total resistance in the circuit is equal to 12 ohms. Don't forget your units and to circle your answer. Next time, we're going to dig into some examples of these, and we're going to work through these problems, try to make sure that we understand how to get everything in our calculator correctly. But hopefully this was a nice overview of understanding what is the difference between a series and a parallel resistor, and then how to solve for the total resistance in each type of circuit. Thanks for tuning in. We'll see you next time.